Something impossible just appeared on a screen at NASA. A shape, faint, long silent. For years, scientists said we would never see it again. It was too fast, too far, gone forever into the dark. But now, the James Webb Space Telescope may have captured something no one thought possible, the first real image of Oumuamua. And if this image is real, then everything we thought we knew about our solar system may change. In 2017, astronomers using the Pan-STARRS telescope in Hawaii noticed something strange moving through our solar system. It wasn't a comet. It wasn't an asteroid. It was something else. It was named Oumuamua, a Hawaiian word meaning scout or messenger from afar. And that name now feels more chilling than ever. Oumuamua was the first confirmed interstellar object ever detected passing through our solar system. It did not orbit the sun like planets do. It did not come from the Kuiper Belt like most comets. It came from outside, from another star system, from the deep unknown. At first, it looked like a small point of light. But as scientists studied it, things became strange. It had no visible tail like a comet. It accelerated slightly as it left the sun, but without releasing gas. It was extremely long and thin, maybe like a cigar, or maybe like a pancake. No one could agree. It was gone. It moved so fast that even the most powerful telescopes on Earth could not track it for long. Within weeks, it faded into darkness. Many experts said we would never see it again. It was a visitor that came and left without explanation. But now, nearly a decade later, whispers are spreading through the astronomy world. The James Webb Space Telescope, the most powerful space telescope ever built, has reportedly captured a deep infrared image of something in the exact projected trajectory of Oumuamua. This telescope can see heat signatures across unimaginable distances. It can detect faint objects billions of light years away. It can peer through cosmic dust. If any instrument could glimpse a fading interstellar traveler, it would be this one. NASA has not made a dramatic announcement. No press conference. No bold headline. But researchers analyzing deep sky surveys noticed an anomaly. A faint, elongated thermal signal moving slowly against background stars. Not random. Not static. Calculated models suggest it aligns with the expected path of Oumuamua if it had not broken apart, if it had not changed direction, if it was still intact. But here's the question no one wants to ask out loud. Why is it still visible? By all previous estimates, Oumuamua should now be far beyond the reach of even Webb's infrared sensitivity. And yet, the data suggests a signature. Structured, stable, not tumbling chaotically like a rock. Is this truly Oumuamua? Or is it something else following the same path? And if the James Webb Telescope has indeed captured the first real image of this mysterious interstellar object, what might that image reveal about its true shape, its composition, its origin? Because if this object is artificial, even in the smallest way, then we are no longer alone in the story of the solar system. And this is only the beginning. Before the image, before the whispers, before the strange infrared signal, there was a moment in October 2017 when astronomers realized something had entered our solar system from the outside. Not from the asteroid belt, not from the Kuiper Belt, but from interstellar space itself. It was the first time in human history we had ever detected a visitor from another star. The object was later confirmed and named Oumuamua. Scientists quickly calculated its path. It was moving too fast to be bound by the sun's gravity. It had already slingshot around the sun and was racing back into deep space at over 87 kilometers per second. That speed meant one thing: it did not belong here. NASA and observatories around the world scrambled to study it. Telescopes turned. Data streamed in. But the window was small. Oumuamua was fading fast. At first, many believed it was just a strange comet. But something didn't fit. Comets release gas when they get close to the sun. That gas creates a visible tail. Oumuamua showed no visible tail. No coma. No dust cloud. And yet, it accelerated slightly as it moved away from the sun. Acceleration without visible propulsion. That detail changed everything. Some researchers suggested trapped hydrogen gas could explain it. Others argued it was a fragment of a distant exoplanet. But one scientist made headlines worldwide. Harvard astronomer Avi Loeb proposed something radical, that Oumuamua could be a thin, artificial light sail pushed by sunlight. Not a rock, not ice, but technology. NASA never confirmed that idea, but they never fully dismissed the mystery either. Then in 2021, the James Webb Space Telescope launched into space. It was placed nearly 1.5 million kilometers from Earth at the L2 point beyond the Moon. Unlike the Hubble Space Telescope, Webb sees primarily in infrared light. That means it detects heat, even very faint heat. Webb was designed to look back in time, to see the first galaxies ever formed, but also scans moving objects. It studies near-Earth asteroids. It tracks comets. It can detect faint thermal signatures long after visible light fades. So when Deep Sky survey data began showing a faint moving object aligned almost perfectly with the projected path of Oumuamua, some researchers felt a chill. The trajectory matched within a small margin of error. The speed was consistent with a decelerating object influenced by interstellar drag. But the signal itself was strange. It wasn't tumbling randomly like most space debris. It appeared to show periodic variation, almost like a controlled rotation. A stable axis. That alone raised eyebrows. Because when Oumuamua was first observed in 2017, data suggested chaotic tumbling, like a thrown stick spinning in space. But this new signal, it hinted at something more stable, more deliberate. And here's the deeper question. If Webb can still detect it, then maybe Oumuamua is not as small or as dark as we assumed. Maybe its surface reflects infrared differently. Maybe it contains material unfamiliar to us. Or maybe, just maybe, it is not inert at all. Could it be that the object that once silently passed by Earth is still active, still emitting subtle energy, still traveling with purpose? If the first real image is confirmed, it won't just show shape. It will show structure, texture, thermal patterns, and those patterns may answer a terrifying possibility. What if Oumuamua wasn't just passing through? What if it was observing? It was supposed to be simple. A rock from another star. A random traveler passing through. That's what the first report said. But the more scientists studied its path, the more the numbers began to whisper something else. Because the trajectory of Oumuamua was not just fast. It was precise. And precision in space is never accidental. When astronomers traced its orbit backward, they confirmed it had entered our solar system from above the plane of the planets. Not from the flat disk where most objects move. It came in at a steep angle. Then it curved perfectly around the sun, using our star's gravity like a slingshot. Gravity assist. The same technique used by spacecraft like Voyager 1 to gain speed and leave the solar system. That similarity was not lost on researchers. Oumuamua passed inside the orbit of Mercury. It skimmed past the sun at close range. Then it accelerated outward on a path that would carry it beyond Neptune, beyond the Kuiper Belt, and into true interstellar space. But here's what made scientists uneasy. The acceleration it showed after passing the sun was subtle but measurable. It wasn't just gravity. Something extra was pushing it. Normally, comets accelerate because sunlight heats their icy surface, releasing gas that acts like a tiny jet engine. But telescopes saw no gas, no dust cloud, no tail. So what was pushing it? Models were built, theories proposed. Some suggested invisible hydrogen gas. Others proposed that it was made of exotic ice. But every explanation had problems. Each required assumptions that had never been seen before in any other comet. Now fast forward to the present. The James Webb Space Telescope is designed to measure heat emissions with extreme precision. It can detect differences in thermal radiation that are smaller than a candle flame seen from millions of kilometers away. If Oumuamua were simply a cold, inert rock by now, it should be nearly invisible. It would have cooled dramatically in deep space. But the faint signal detected in Webb's data suggests something else. A slight but persistent thermal irregularity. Not bright, not dramatic, but measurable. Even more strange, the movement appears consistent, not chaotic, not tumbling wildly. Back in 2017, light curve data suggested Oumuamua was tumbling unpredictably, flipping end over end in a complex rotation. That kind of tumbling should continue forever in the vacuum of space. But if Webb's new detection is accurate, the rotation seems stabilized. Stabilized. That implies either the early measurements were incomplete or something has changed. And here's the chilling part. Objects in space do not simply self-correct their spin without external force. There is no air resistance, no friction, no natural stabilizer, unless there is internal mass distribution or active adjustment. Could an object from another star system carry internal structure? Could shift weight? Adjust orientation? The idea sounds like science fiction, but so did interstellar visitors before 2017. And now, another layer emerges. Because if we compare its path with our own outbound messenger, Voyager 1, we notice something eerie. Both are leaving the solar system. Both cross the heliopause. Both now travel in interstellar space. Two messengers. One from Earth, one from somewhere else. What if their paths are not just random lines in space? What if they intersect in ways we have not yet understood? And what if the first real image from Webb is not just a picture, but evidence that the object we thought was drifting away is still doing something we cannot yet explain? It wasn't a bright flash. It wasn't a loud transmission. It was something quieter, stranger, hidden inside background noise. A faint electromagnetic signature buried in deep space data. And when analysts filtered the infrared readings from the James Webb Telescope, they noticed a pattern. Not random, not chaotic, a pattern that seemed structured. For decades, NASA has monitored electromagnetic signals from beyond Earth, from pulsars, from distant galaxies, from our own spacecraft, like Voyager 1, which still sends faint radio pulses from beyond the heliosphere. Signals from space usually follow known physical rules. Pulsars pulse with clock-like precision. Stars emit radiation based on temperature. Comets reflect sunlight. Everything has a natural fingerprint. But the faint return detected along the projected path of Oumuamua does not fully match known patterns. The James Webb Space Telescope, an advanced infrared observatory, measures heat signatures across wavelengths invisible to human eyes. When its instruments captured this object, the thermal readings fluctuated in a repeated cycle. Not perfectly mechanical, but not random either. It almost resembled modulation. Modulation means change with intention. Now, let's be careful. NASA has not declared alien contact. No official statement says this object is artificial. But scientists studying raw infrared datasets noticed something subtle. The object's brightness varied in intervals that seemed too organized for natural tumbling. Natural rocks spin unpredictably after billions of years of collisions. They wobble. They drift. Their heat signatures change unevenly. This signal appeared smoother, almost controlled. Some analysts suggested that the modulation could be caused by uneven surface materials, perhaps one side darker, one side reflective. That would create repeating thermal variation as it rotates. But that explanation only works if the rotation is stable. And as we discussed earlier, initial observations in 2017 showed chaotic tumbling, a complex spin state. So what changed? If an object tumbling wildly in 2017 is now rotating in a steady, periodic manner, then something influenced it. But in the vacuum of interstellar space, there's almost nothing to influence an object. The density of particles is near zero, unless it interacted with something. Interstellar magnetic fields? Cosmic dust clouds? Or something even more structured? Here's another detail that deepens the mystery. Webb's infrared detection suggests the object is retaining slightly more heat than expected for its distance from the sun. That could mean it has unusual thermal properties, perhaps metallic components, perhaps layered structure, or internal energy retention. Remember the golden record aboard Voyager 1, a message humanity sent into the cosmos, a time capsule meant to be discovered. It carries sounds of Earth, images, music, our existence recorded on a golden disc. We sent a message outward. What if something else sent one inward? The idea is unsettling, but not impossible. The universe is vast. Billions of star systems. Countless planets. If even one developed advanced intelligence millions of years before us, their probes could already be exploring. Silent. Small. Unnoticed. Until now. Because if the first real image from the James Webb telescope confirms structured geometry, sharp edges, or uniform surfaces, then we're not just looking at a rock. We may be looking at a messenger. And the real question becomes terrifyingly simple. Was it only passing through? Or was it mapping us? If you want to see what happens next, hit subscribe and don't miss this cosmic journey. Long before telescopes, long before rockets, long before NASA, humans looked up at the sky and saw patterns. They saw visitors. They saw gods descending from the stars. And now, with a possible real image of Oumuamua, some are asking a strange question. Have we seen something like this before and just didn't understand it? Ancient civilizations were obsessed with the heavens. The Maya built pyramids aligned with Venus. The Egyptians aligned the Great Pyramid with Orion's belt. Sumerian tablets describe beings descending from the sky. Across cultures, across continents, the same theme appears, something arriving from above.